गुड मॉर्निंग टू ऑल ऑफ यू गाइस। गुड मॉर्निंग ऑल ऑफ यू। कैसे हैं आप सब लोग? गुड मॉर्निंग शुभम, गुड मॉर्निंग। चलिए सब लोग आ जाइए। आई वांट ऑल ऑफ यू टू बी लाइव हियर। गुड मॉर्निंग टू ऑल ऑफ यू, गुड मॉर्निंग गाइस। Today this topic is very important for all of you because this topic is not only important in the uh, numerical part, it is important for the theoretical part also. If you are giving GATE or if you are giving ESE exam, if you are giving SSC exam, in all the type of exam, you will find some question from boundary layer. And even real life also, so many applications are there that is totally based on boundary layer. तो फटाफट सब लोग आ जाइए। बहुत ही मजेदार टॉपिक है और आज की क्लासेस जो है थोड़ी लंबी चलेगी और मजा भी उतना ही आएगा। यू विल नॉट फील दैट कि बहुत ज्यादा आवर्स हो रहे हैं, बट आपको मजा आएगा। चलिए, बिफोर दैट आई वांट ऑल ऑफ यू टू बी लाइव फर्स्ट, एंड दोज हु आर लाइव, share this as much as possible right now. Share this link in all the group. You have time because this chapter is a new chapter, so that is the reason I am requesting to all of you to share this in all the group which you know. जितने भी ग्रुप आपके हैं इंजीनियरिंग बच्चों के, आप उसमें सेंड कीजिए और देन वी विल हैव अ डिस्कशन about the previous topic, that is a dimensional analysis. If you have any doubt regarding that, you can ask me, and then I will start the boundary layer theory. For all of you guys. चलो 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 सब लोग आ जाओ. I want all of you. I will tell you the complete boundary layers theory in a single story. And if you remember that story, everything will be clear to you. Chalo. So by the time you guys are sharing, let me introduce myself. My name is Mrigank, expert in GATE, ESE and other technical exam for subjects like environmental engineering, fluid mechanics, open channel flow. Two more subjects with environmental sciences also already have started, and with that now a new subject is also going to come that soon you will get informed about that. And you all guys are knowing that I have done my master from NIT Warangal, and the subject is environmental engineering. And after that, started my research work in BARC, and after that, I started my teaching career, and now it has been more than 3 years continuously in the same field only. And MRI10, you all guys are well aware of this code. This is something which is used not only for 10% off, or you can say in an Unacademy subscription, but you can also use this code if you want my suggestion, or if you want my you can say the guidance during your preparation work. In that case, I will be always with you. And one more purpose also, you can use this MRI10, whatever PDF like class PDFs and all, whatever I'm sharing with you, this MRI10, this is the code which you can use it for all the class notes. Sure. With that, guys, let me tell you the brief detail about the plus subscription. What are the things you are getting in the plus other than the YouTube? Is that first thing is the security that your course will complete on time. So I always suggest to all of my students that those students who are planning to crack GATE or ESE or to any other exam, then join plus. And those who are here for one or two subjects, they only want to learn fluid mechanics, or they only want to learn environmental engineering, they only want to learn geotech. In that case, you can go with the YouTube. No need of taking plus in that case, if you are here for one or two subjects. But if in your mind it is clear that I am going to take GATE and ESE, in that case the plus will be best for you. Other than that, we have some other features also in a plus, like crash course, rank improvement batch. Uh, every course will be in English and Hindi also. Doubt solving session, weekly test. These doubt solving session is very important. If you want to make an interest on your subject, your doubt has to be cleared. And that your doubt, if it is cleared in front of faculty or in front of a student, you can say, it will be much more in a clear way. Next thing is the weekly test. Weekly test is only to assess your performance, whether you are going in a good direction or not. And the Fees detail, you guys are well aware that as you are taking for 12 months, now we have given 18-month course also. So as you are going from 12 to 18 to 24 month, you can see the per month cost is for 12 month it is around 2,269 per month. For 18 month it is around 1900, and for 24 month it is around 1600 per month. And that is the beauty of that. So those guys who are in second and third year, I always suggest go for 2-year course, because you have enough time to prepare, and prepare in a better way. Prepare in a better way. Chali. With that, guys, regarding things, the courses which we are providing in YouTube, you can also watch them. And these are my Unacademy profile. It's not the updated one, but the link is correctly matched, so you can use this profile for all the workout session which I have taken for fluid mechanics, as well as today also I am going to take a complete 30 question, that too important 30 question of your fluid mechanics, which are important for GATE 2021. And timing is 1 p.m. to 4 p.m. So it is a 3-hour session, and you guys are going to love it. So we'll meet again after this class. We'll meet again at 1 p.m. And GATE aspirants group, you all guys are well aware of this group, as well as the Unacademy GATE ESE Telegram channel. That also you guys are well aware of. Here you will get all the class notes, as well as class notification of not only my subject, but all the faculty information. You will get it, and that's the beauty of this Telegram group. So with that, this is the Unacademy GATE C channel, guys. Those who are learning from first lecture, they know that we are providing the best quality content at a single platform. So don't forget to subscribe. And with that, let me start the beauty of the beauty. I will say the beauty of the fluid mechanics is boundary layer theory. Boundary layer theory. It is a beauty. I will say it's a beauty. Chalo. So before that, I think some of you guys have joined. So good morning to all of you. Good morning, Adil, Amulya, Aman. So today is a new topic. So again, I'm requesting all of you guys to share this link in all the group which you are already there, like in any other group. Share in all the group, so that all student, I want all student to be here. I want all student to be here. मैं सारे स्टूडेंट को यहाँ चाहता हूँ. So first of all, if I will start with the boundary layer theory, 2 points I will tell you. First thing, the boundary layer theory is first started by Ludwig Prudential. And the year was 1904. Like for India, before independence itself, they are started discussing about boundary layer theory. And who started this? Ludwig Prudential. It's as I told you, I will tell you the complete boundary layer in a story format, so that you all will remember. So please focus it here. Now, before starting the boundary layer, something I want to make it clear. Inside boundary layer, first point, viscous and inertial force are causing flow to be rotational. What I said, that whenever the viscous flow will be there, this I have discussed in fluid kinematics also, that in a case of viscous flow, that flow will be rotational. Why it is rotational? For example, if this is moving, this is the translational movement, and if viscosity is there, chances of rotation will be more. Why? Because because of the obstruction. Because of the obstruction, it will rotate, it will rotate, it will rotate, it will rotate. That is the beauty of, that is the beauty in that case. In a viscous flow, the flow, because of the viscous, you can say the flow is nothing but the rotational. Is that clear to all of you? First, before telling anything about boundary layer, inside boundary layer, whatever things will be there, that's something I'm telling to you. Please focus it here. Please focus it here and try to write down. Try to make your notes today itself. आप यहाँ पे notes बनाइए. थोड़ी थ्योरी भी लिखवाऊंगा, लेकिन notes अच्छे से बनाना, प्यार से बनाना notes. ये आपके बाउंड्री लेयर का सबसे बेस्ट नोट्स होने वाला है, तो ध्यान से बनाना. नेक्स्ट थिंग, जीरो और यूनिफॉर्म प्रेशर ग्रेडियंट is observed over a flat plate. Over a flat plate. Please note it down this part. Please note it down this part. सब लोग नोट कीजिए यहाँ पे. Marks for boundary layer. The weightage for boundary layer will be around, you can say 3 to 4 marks. 3 to 4 marks. For boundary layer, generally 3 to 4 marks will be there. In a fluid mechanics, it will be 3 to 4 marks. Chalo. Everyone note it down. Everyone note it down. Chalo. Now let me draw something for you. Let me draw something for you. You guys can just wait. Let me draw first, then you can draw also. Something beauty you are going to learn. So please focus it here once. सब लोग आराम से पहले देखिएगा मैं क्या क्या कर रहा हूं. Then only you have to write. I will tell you when to write, so don't write it now. Chali. So first of all, understand everyone. First of all, understand everyone. What is happening here? What is happening here? पहले इस बात को समझिएगा सब लोग. What happens in a normal flow? In a normal flow, flow हो रही थी, viscosity थी, flow आपकी हो रही थी. So now, what you have done? You kept a plate, you kept a flat plate, or you kept a plate. और उसके बाद क्या हुआ? After that, what happens? A boundary layer is formed. A boundary layer is formed near to that plate. You will say, sir, how this boundary layer formed? That you have not discussed. I will discuss you that part also. First listen. So if you are putting a flat plate, what will happen? You will find that some boundary layer is formed. So your question will be, sir, what is that boundary layer? So let me go with the basic. Go with the basic. For example, if this flow, this stream is having some velocity u infinity that we call as stream velocity or free stream velocity. Now, near to that plate, what will be the velocity? You know that you all guys are well aware of the no slip condition. आपको ये नो स्लिप कंडीशन मालूम है या नहीं? मैंने कहा बताया था in a first chapter. So in a first chapter I told you about no slip condition. What is that no slip condition? I told you that no slip condition means what? the fluid layer which are attached to the boundary will have the same velocity. The fluid layer which is attached to the boundary will have the same velocity as what boundary having, as what boundary is having. That means if boundary is stationary, so the fluid layer which is attached to that, just attached to that, if that layer will also will have zero velocity. If boundary itself is moving, in that case that layer will also move with the same velocity. That's something we call as a no slip condition. No slip condition. I hope it is clear to you. So if your flat plate is stationary, you will find what? You will find that at this point the velocity is zero. Near to the wall, the velocity is zero. And as you are going away from the wall, your velocity is increasing, your velocity is increasing, your velocity is increasing, your velocity is increasing, your velocity is increasing. So this is something we call as the velocity is changing as you are going away from the boundary, and it tries to meet what? U infinity. But actually कितना पहुंच पाता है? 0.999 U infinity. That means after some point, if you are going very much far away from what? The boundary, you will find the original free stream velocity which is going on, that is U infinity. So this part which I have shown to you, that is 0.99 U infinity, that's something you need to learn that. So if you look at here, dear, here in the less distance itself, there is a change in velocity from 0 to 0.99, from 0 to 0.99 U infinity. So if there will be a change, in that case definitely a velocity gradient will be formed. Yes or no? अगर यहाँ पे change होगा, so there will be a velocity gradient or not? My question is that for all of you, whether there will be a velocity gradient or not. ये question मेरा आप सबसे है. I'm asking to all of you. It's a story, dear. So जो लोग बीच में छोड़ के जाएंगे वो लोग फिर बाद में कभी नहीं समझ पाएंगे. So I want all of you to please focus it here. चलो. What I said that as you are going away from the boundary, the velocity is increasing, and at a particular point, the velocity will be equal to the 0.99 times of U infinity. Up to that point, the depth we are telling as y. So you can see that in the y depth, there is a change in the, or you can say this depth is also delta also. So this delta is nothing but the depth of that boundary layer where the velocity is changing from 0 to 0.99 infinity. So in that case, definitely a velocity gradient will form. But क्या लगता है कि उसके बाद velocity gradient नहीं होगा? Do you really think after that the velocity gradient will not be there? It will be there, but U 0.99 to U infinity, 0.99 in U infinity to total U infinity, that will occur in a very long span of length. In that case, the velocity gradient will not be so high as compared to the boundary layer. तो boundary layer में क्या हो रहा है ना कि the dv, the change in dv, and that too with a very less dy, अगर dv ज्यादा है और dy कम है, so the value will be what? Very much high. So in that case, the velocity gradient which is formed is very high, and you know that wherever the velocity gradient will form, what I said here, that wherever the velocity gradient will form, shear stress will be there. Because you know that formula tau equal to mu into dv upon dy. So wherever the dv upon dy is there, and that too high dv upon dy is there, definitely the shear stress will form. So what we have seen, because of this, what we have seen, near the boundary layer, you will find that fluid particles are retarded, and it is making a layer like this. So up to this, the layer we call as laminar. After some point, we are not able to judge it, so that's something we are telling as transition. After some time, it is called as turbulent. It is called as turbulent. So if you notice here, from the leading edge to the trailing edge, from the leading edge to the trailing edge, that the depth of the boundary layer is increasing. The depth of the boundary layer is increasing. So if the depth of the boundary layer is increasing, why it is increasing? Your question will be there. Why is increasing? Your question will be there. So for that, remember that. For that, remember that. Like for example, your body. Take example of your body. अगर आप पानी में जाते हो तो स्टार्टिंग में आपका कम आप क्या होता है कि आपको झटका ज्यादा लगता है, बट द एरिया विल बी लेस, क्योंकि आपका सर का एरिया कम है. बट एज वाटर कम्स टू द middle part of your body, middle part of the body, in that you will find that too many disturbances are there. In that case, it is going with the transition. After some time, the area of exposure will be very much high. As the area of exposed will be more, जितना ज्यादा एरिया से एक्सपोज होगा उतना ज्यादा आपका क्या होगा, स्ट्रीम जितना भी फ्री स्ट्रीम वेलोसिटी है उतना ज्यादा एक्सपोज होगा एरिया से, उतना ज्यादा रेजिस्टेंस होगा. So if the area exposed is too much, in that case the resistance will be too much, in that case the retardation will be too much, in that case the depth will be more, the boundary layer depth will be more. Have you got this point? क्या आप लोगों को ये पॉइंट समझ में आया? आई एम आस्किंग टू ऑल ऑफ यू डियर, सब लोग आराम से बताना मेरे को. हैव यू गाइस अंडरस्टूड दिस और नॉट? Why boundary layer thickness is increasing from leading edge to the trailing edge? Because if you are going from the leading edge to the trailing edge, the area exposed is getting more increasing. The area exposed is getting increased. In that case, definitely the resistance will also increase. Resistance will increase. That means retardation will be more. Retardation will be more. That means the boundary layer thickness will be very more. In that case, I think you guys have understood this. If not, then please tell me. If not, then please tell me. Till now, I have not told you to write anything. Till now, I have not told you to write anything. So please focus it here. Please focus it here. मैं आपको लिखने का टाइम दूंगा बच्चा, तो लिखने में अभी टाइम दिमाग मत लगाओ. लिखने में अभी don't waste time in writing right now. First, clear all the doubt. Then we'll discuss that part. Then we'll write down each and everything. मैं सारी चीजें आपको लिखवा दूंगा, एक एक चीजें आपको लिखवा दूंगा. तो आप पहले यहां देखो. चलो, इज दैट क्लियर टू ऑल ऑफ यू? चलो, अब जो भी बातें की है ना, लेट मी राइट डाउन. ठीक है, तो व्हाट यू वांट, आई एम आस्किंग टू यू, बिकॉज हियर आई एम गोइंग टू गिव यू सम थ्योरेटिकल पार्ट आल्सो. तो आप क्या चाहते हो, मैं ओरली डिस्कस कर दूं और आई राइट ऑन बोर्ड, राइट ऑन स्क्रीन? मैं क्या करूं, स्क्रीन पे लिख दूं या मैं ओरली डिस्कस कर दूं? व्हाट यू वांट फ्रॉम मी? जल्दी रिप्लाई करना, आप सब लोग जल्दी रिप्लाई करना, because the explanation part is very important for you. So whatever I explain now, I want you to write down in a written format also, so that you can read this after 1 month also. You will get everything. Chalo, tell me dear. So Aman is telling me, sir, please repeat it once again. What I'm telling you, Aman, as you can see, from the leading edge to the trailing edge, the area exposed is more. Take example of your body. आप अगर बॉडी मूव कर रही है तो आपको यहाँ पे क्या है, एट द हेड एरिया इज लेस. as you are going, your area of exposure is getting more. So in that case, you will find that the boundary layer thickness is also more. Why? Because if area exposed is more, the friction will be more, retardation will be more, more boundary layer thickness you will find. I hope it is clear to you now. What will be okay? I want reply from all of you. क्या सही रहेगा? You want me to orally give that part, or else I will write down for you. तो राइट डाउन में एक चीज का ध्यान दीजिएगा, आप लोग पैरेलली मेरे साथ लिखिएगा. यू गाइस हैव टू पैरेलली राइट विथ मी ओनली. थोड़ा थ्योरी है, सो आराम से लिखिएगा. चलो, सो व्हेन a real fluid flows passes a solid boundary. देखना, जो मैं आपको लिखा रहा हूं ना, वॉट एवर आई एम गिविंग टू यू, इफ यू जस्ट रीड दिस, everything will be clear to you. So while writing, try read this line also parallelly. So when a real fluid flow passes a solid boundary due to no slip condition, due to no slip condition at the boundary, at the boundary, the velocity of fluid will be, the velocity of fluid will be same as that of, same as that of, same as that of the boundary, same as that of the boundary if boundary is at rest, if boundary is at rest, the fluid, the boundary is at rest, the fluid will also have zero velocity. Zero velocity. Remember this point. Remember this point. Next, away from the boundary. This theory part is very important. That is the reason I am writing here. मैं इतनी मेहनत इसलिए कर रहा हूँ because this complete story is very much required for you to learn. Otherwise, what will happen now? You will not understand what is actually that boundary layer. So please write down and try to read this line. Try to read this line. Away from the boundary layer, away from the boundary, the velocity increases at some distance, at some distance, at some distance, at some distance away from the boundary, the velocity increases, and at some distance it reaches free stream velocity. The reason in which there are velocity gradient which is formed, velocity gradient which is formed are known as boundary layer region, are known as boundary layer region, are known as boundary layer region. Next point, the flow in a boundary layer region, which I have already mentioned you, boundary layer region are viscous in nature. Are viscous in nature. Now, if you write this, if you have written this, then you have to draw this diagram. Then you have to draw this diagram. इसके बाद अपने notes पे ये वाला diagram बनाना. If you have written this statement which I have given to you, it's a long but it's very much required for you. So if you have written that statement, then draw this diagram. Boundary layer means velocity variation na. Boundary layer forms because of the velocity variation. Boundary layer formed because of the velocity variation. Plate is having some area now. Yes, dear, plate is having some area. You can take example of this. You can take example of this. This can be your plate. 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 So it is having some area. Na? It is having some area na? On both the side. It is having some area. चलो. Now I want from all of you. मेरे साथ में रहिएगा और बताते जाइएगा सब लोग. I want reply from all of you. Till now it is completed. Till now it is completed to all of you. क्या यहां तक आप लोगों ने कंप्लीट कर लिया? Have you guys completed till now? Have you guys completed till now? The diagram part as well as the written theory which I have given to you. Is all is clear or not? ये सारी चीजें क्लियर हुई या नहीं हुई? So up to this you have understood that because of the velocity variance, a layer is formed. That's something we call as boundary layer. That's something we call as boundary layer. Is that clear? Is that clear? Best example, Vashu, so for your understanding, you can take example of human body, or if you take example of even aeroplane. In aeroplane, at the starting, you will find less area in contact, but as the air go inside to that or in between to that, more area will be in a contact. So there also you can take example. There also you can take. Is that clear? Chalo. Something more. Everyone ध्यान से देखिएगा. Look at everyone. Due to velocity gradient, shear stress is developed inside the boundary layer. Inside the boundary layer. And beyond the boundary layer, this is a very important point. Beyond the boundary layer, dV upon dy, that is the velocity gradient, is negligible. This point is very important because people will ask you in an interview that the velocity gradient is only there in the boundary layer or outside boundary layer it is also there. Yes, outside boundary layer also it is there, but the velocity gradient is very small. Why it is very small? Because the change in velocity is only from 0.99 u infinity to u infinity. So change is very small, and the distance, this much change is occurring. The distance is very much high. So dV upon dy, if the denominator is very much high, so dV upon dy value will be very much low. In that is the reason we are telling that dV upon dy is negligible. That doesn't mean that dV upon dy will not be there. It will be there. One of the important question which interview they will ask you. So please, एक point जो मैं आपको बता रहा हूँ ना, I'm telling you that each and every point here is very important. ध्यान से सुनो, ध्यान से लिखना. If you are getting any doubt, please ask. चलिए, next point. Up, before giving you the next point, let me go to the diagram again. If you see that I have written laminar, transition, turbulent. I have given a statement that this part will be laminar, this part will be transition, this part will be turbulent. As I told you already that laminar, turbulent, it is a flow condition. It can occur anywhere. But now my question is that why it is laminar, why it is transition, why it is turbulent. So if a fluid is flowing, in between you have put you can say the flat plate and all. What happens at the starting? It will be a completely you can say the layered by layered flow. In that case, we call it laminar. after some time when the area exposes very much in abrupt way, in that case we are not able to finalize whether it's a laminar or turbulent. In that case we are going with the transition, and that after some time we are easily able to tell that this flow is very much in turbulent state. In that case it is turbulent boundary layer. So now many people are having doubt, many people are having fallacy, many people are having misconfusion that in a flow, remember this point, in a flow, if a flow will be laminar, then only laminar will exist. If a flow is turbulent, then only turbulent layer will exist. No, dear. Always remember, irrespective of this point, I will write it also. This point I will write it also. First understand, then I will write it also. Irrespective of whether flow is laminar, turbulent, transition, I doesn't care at all. In this flat plate, first it will be the laminar, second it will be the transition, and the third will be the turbulent. Is that point is clear to all of you? Very important question for ESE as well as the interview. That irrespective of whether the flow is laminar, turbulent, transition, I don't care. In the flat plate, the first thing will be the laminar, second thing will be the transition, and the next thing will be the turbulent. Is that clear to all of you? Is that clear to all of you? That the first point I told you. Second point. If the pressure gradient is changing, if the pressure gradient is changing, that means what? If your pressure gradient is changing, in that case what will happen dear? क्या होगा आपकी इस चीज में, इस कंसेप्ट में क्या होगी? जब आपका प्रेशर ग्रेडियंट बढ़ रहा होगा, तो आपकी वैल्यू क्या होगी? आई वांट रिप्लाई फ्रॉम ऑल ऑफ यू. Or in a opposite way, if I will ask you, if your pressure is decreasing, तब क्या होगा? I think that will be easy for you, because if your pressure is decreasing, that means the velocity is increasing. Based on the Bernoulli equation. So if your pressure is increasing, the velocity pressure is decreasing. So velocity is increasing. So if velocity will be more, the boundary layer thickness will be less. That means आप समझना, जब आपका बॉडी वाटर में बहुत फास्ट मूव करता है तो कम पानी कब आपके एरिया में टच होता है ना, आपके बॉडी में कम पानी टच होता है ना. लेकिन अगर मैं आपको स्लो मूव कर रहा हूं, इफ आई एम मूविंग यू वेरी स्लोली, मोर एरिया विल बी इन कॉन्टेक्ट ना, आपका शरीर ज्यादा वेट होगा ना. Same logic here also. That if you are going with a very fast velocity, chances of boundary layer formation will be less. In that case, dear, the boundary layer thickness will be less. So if negative pressure gradient will be there, the boundary layer thickness will be less. I hope you got this. If you have any doubt, you can ask me. If you have any doubt, you can ask me. So first point I told you, second point, this is the second point which I told you. Now the third point. What we have seen there, in the turbulent boundary layer zone, especially for the smooth boundary, a small layer is very, I will say, although this boundary layer thickness is very small, in that also a very small thickness is there. That layer we call as laminar sublayer. Why we call this laminar? Because what we have seen that near to the boundary, in a turbulent boundary region, we have seen that the layer is showing laminar nature, you will see. The layer is showing the laminar nature or laminar behavior. So that layer we call as laminar sublayer. It happens only in case of smooth boundary. So that is the third point and very important point for interview as well as the exam point of view. These all points I will give it to you. So I just want all of you, these 3 points are clear or not? मैं आप सबसे पूछ रहा हूं. I'm asking to all of you dear. Is that the third point is clear to all of you or not? Is that clear or not? If more area is also there, in that case leading is, first of all, Vashu, more area कोई भी static lead में नहीं रखता है. जनरली आप कभी भी नहीं देखते होगे मोर एरिया रहता है लीडिंग एज में, बट अगर वो रखते हैं तो भी लेमिनार लेयर ही फॉर्म होगा. इज दैट क्लियर टू ऑल ऑफ यू? इज दैट क्लियर टू ऑल ऑफ यू? So this is the third point which I told you. This is the third point which I told you. ये आपको मैंने third point बता दिया. That's something we call as. That's something we call as. That's something we call as. Everything I've told you. Everything I told you. So some people are telling, sir, first point and third point is not clear. Please repeat it once again. Please repeat it once again. Okay, I'm repeating once again. I'm repeating once again for you. First point I told you that irrespective of whether your upstream flow is laminar or turbulent or transition, irrespective of that, in a boundary layer, always first laminar will form, then transition will form, then turbulent will form. Always it will happen, irrespective of whether the incoming fluid flow is up laminar or turbulent or transition. उस पर depend नहीं कर रहा. Second thing what I told you that in a negative pressure gradient, if there is a negative pressure gradient means what? At the leading edge the pressure is less, pressure is more. At the trailing edge the pressure is less. In that case it is a negative pressure gradient. If negative pressure gradient will be there, velocity will be more. The boundary layer thickness will be less. That is the reason I told you. That is the second point. Now third point what I told you that in a turbulent boundary layer region, what we have observed that a very small thickness of layer which are just attached to the boundary, and boundary also what? It's a smooth boundary which is just attached to the boundary. It is showing similar behavior as the laminar boundary layer. That layer we call as laminar sublayer. This is the third point. Now I am going to tell you the fourth point also. Actually, in a laminar boundary layer, velocity distribution will be what? I have told you already. In a laminar, velocity distribution will be what? It will be parabolic. But in a laminar sublayer, even though it's a parabolic, but as the thickness is very small, we are taking that as linear. तो आपको मालूम है कि ये पैराबोलिक होता है, बट थिकनेस इतनी कम है तो इसको आप लीनियर बोलते हो. But actually the velocity variation in that laminar sublayer is parabolic. Remember that point. Remember this 4 point. Very important point for all of you. Remember this thing. And if this thing is clear, then I will give you then I will give you each and everything in written format. तभी मैं आपको written format में दूंगा. पहले आपको ये चीजें समझ में आई orally या नहीं. I want to make it clear whether you guys have understood these concept orally or not. I will give you each and every point, whatever point I told you now just now, every point I will give you in a written format. But before that, I want all your doubt first. So first of all, let me take Aman and Amulya. क्या आपका first and third point clear हुआ बच्चा? अमन और अमूल्य बताइए कि आपका फर्स्ट एंड थर्ड पॉइंट क्लियर हुआ बच्चा? अमन इज आस्किंग नाउ कि सर हाउ बाउंड्री लेयर थिकनेस डिक्रीजेस विद इंक्रीज इन द वेलोसिटी इज नॉट क्लियर. अमन, अगर ज्यादा वेलोसिटी रहेगी तो आपको लगता है कि ये जो आपको वेलोसिटी वेरिएशन फॉर्म हो रही है वो होने देगा? आपको लगता है? सिंपली सी बात है, अगर मैं किसी बॉडी को वाटर में बहुत फास्ट स्पीड से ले जाऊं, so do you really think more area will be in a wet condition? No. जब आप स्लो लेके जाते हो ना, तब ज्यादा एरिया आपका वेट होता है. Is that clear to all of you or not? चलो, so next thing is शशांक, आप second point already I have repeated. शशांक, you are asking laminar sublayer कहां से फॉर्म होना चालू होगा? Laminar sublayer will be in a turbulent boundary zone. This is the turbulent boundary zone. This is the laminar boundary zone. This is the transition boundary zone. So in a turbulent boundary zone, this laminar sublayer will be formed. So शशांक, अमन, अमूल्य, सबके डाउट क्लियर हो गए? क्या आप सबके डाउट क्लियर हो गए बच्चा? देखो, orally I want to make this clear because I know this concept is new for you guys. तो मैं आराम से चल रहा हूं. एवरीथिंग आई एम गिविंग इन रिटन फॉर्मेट आल्सो. तो हड़बड़ी नहीं, आराम से कहानी सुनते जाओ और थोड़ा पेशेंस रखो बच्चा, कि हर चीजें बताऊंगा. हर चीजें बताऊंगा. इट्स माई गारंटी दैट. चलो, इज दैट क्लियर? चलिए, अब आपने डायग्राम तो बना ही लिया है. नाउ गिव मी समथिंग इन अ थ्योरी फॉर्मेट विच यू गाइज हैव टू राइट डाउन इन योर नोट्स, चलो, सब लोग ध्यान से लिखना, सब लोग ध्यान से लिखना, सब लोग ध्यान से लिखिएगा. आई एम पुटिंग दिस पैराग्राफ हेडिंग एज डिस्कशन. सो मैं इसलिए लिख रहा हूं ना क्योंकि आप लोग बाद में भी पढ़ सको. व्हाई आई एम राइटिंग दिस ऑल थ्योरेटिकल थिंग, व्हाई? बिकॉज यू कैन रीड दिस again and again. It will be clear, it will be completely crystal clear to all of you. चलिए, तो साथ में बोलते बोलते लिखेंगे. when a real fluid when a real fluid flowing over a flat plate when a real fluid flowing over a flat plate the boundary layer thickness is zero at leading edge at leading edge at leading edge. Next, retardation of fluid particle increases as more area of plate is exposed, as more area of plate is get exposed, as more area of plate get exposed to the flow, and hence the boundary layer thickness increases. Hence the boundary layer thickness increases. Hence the boundary layer thickness is increases. So boundary layer thickness, the increase in the boundary layer thickness is not only depend on this thing. Some other parameters are also there that I will also discuss you when I will give you the formula of boundary layer thickness. Now, then I will discuss all these details. So please have some patience and note it down fast. मेरे साथ नोट करते जाइए, सब लोग. Hence the boundary layer thickness is increases as the distance from the leading edge increases. That means as distance from the leading edge increases, that means you are going way below way into the you can say the flat plate. In that case, your boundary layer thickness will increase because more area will be exposed to that. Chaliye. Next, up to certain distance from the leading edge laminar boundary layer will be formed. Laminar boundary layer will be formed irrespective of the irrespective of the irrespective of the fact that irrespective of the fact that approaching flow is laminar or turbulent. And this is very important point. Your first important point था that up to certain distance from the leading edge, laminar boundary layer will be formed irrespective of the fact that approaching flow is laminar or turbulent. उससे फर्क नहीं पड़ता, laminar boundary layer form होती है. Second thing, second point. Everyone look at the second point. Everyone look at the second point. Look at the second point what I'm giving to you. As laminar boundary layer grows, instability occur and flow changes from laminar to turbulent. So as laminar boundary layer grows, instability also occur and the flow will change from laminar to turbulent. So first, this don't say this as a second point, it's a continuation of that. तो इसको second point बोलना गलत होगा. That is the first point and a very important point of discussion while interview as well as for 1 mark question. ये बहुत पूछा जाता है, ध्यान रखना. चलिए. I'm hoping that you are writing parallelly with me, so I'm not giving time to write down. मैं आपको लिखने के लिए टाइम नहीं दे रहा हूं. Why? Because I'm hoping that you are writing parallelly with me. So second point. Now second point, what is that? If the plate is smooth, देखिएगा जो मैंने आपसे डिस्कस किया था same thing I am writing also. If the plate is smooth, then even in the turbulent boundary zone, there is a very thin layer adjacent to the boundary where the flow is showing laminar nature or laminar behavior. This layer is called as laminar sublayer. This layer we call as laminar sublayer. और उसकी थिकनेस जो हम कैसे बताते हैं? विद डेल्टा डैश. इसकी थिकनेस हम क्या बोलते हैं? दिस थिकनेस वी कॉल एज डेल्टा डैश. This something we call as delta. This will be delta laminar. This will be delta turbulent. And this laminar sublayer thickness we represent with delta dash. And here I am going to give you the very important formula. Sometime they will ask you for 1 mark. Delta dash will be equal to 11.6 nu. What is nu? Kinematic viscosity upon V star. So up to this you have written. Up to this you guys have written chalo. So this is something 11.6 nu upon V star. You know what is V star? There is a shear velocity. That's something I have discussed during a laminar flow. And nu, you guys are well aware, that is kinetic viscosity, that is mu upon rho. तो मेरे को I don't think I need to give you what is mu and rho. मैं ऐसा आपको लिखने की जरूरत नहीं है, आप सब लोग लिख लोगे. So up to this, write it down. And if it is completed, please tell me. So up to the second point I have given to you. Up to the second point I have given to you. हर एक पॉइंट मैं आपको लिखवा रहा हूं, so that if you are watching this lecture after 5 months also, everything will be clear to you. एक बार बस आप पढ़ लेना इसको. सारी कहानी क्लियर नहीं हुई तो मेरा नाम बदल देना. तो एक बार आराम से पढ़ना. ये सारी चीजें मैंने आपको लिखवाई है ना, ये मैंने बहुत प्यार से लिखा है बच्चा. So please write down that, and while writing try to read this line also. इसलिए मैं आपको लिखाते वक्त भी बोल रहा हूं, so that you will listen na. Every story will be clear to you. Chalo, next point, again very important point for you. I will give you 3 star for this. Very important point. Look at what is the third point. Velocity profile in laminar sublayer is parabolic, or is actually parabolic, but as the thickness of laminar sublayer is very less, it may be taken as linear. Now the fourth point, more negative pressure gradient reduces boundary layer thickness. More negative pressure gradient reduces boundary layer thickness. मैंने जो 4 पॉइंट आपसे डिस्कस किए थे, whatever that 4 point which I have discussed with you, I have given these all points in a written format also. अब मैं आपसे पूछ रहा हूं, because now I am going with the numerical part. अब मैं आपको numerical वाले part में जाऊंगा, that I will give you some formulas also. So before this, I want from all of you, have you understood the complete story or not? आपको story समझ में आई कि नहीं? क्यों boundary layer form हुई? How it is there? What is the behavior of this? What something we have observed? Is that complete detail is clear or not? और मैं जितने लोग लाइव हैं सबसे पूछ रहा हूं बच्चा, क्योंकि मैं मेहनत से पढ़ाता हूं, तो आई एम एक्सपेक्टिंग यू गाइस टू कोऑपरेट विथ मी. तो बताओ जल्दी से कि इज दैट कंप्लीट स्टोरी इज क्लियर और नॉट? क्योंकि जब स्टोरी क्लियर नहीं होगा ना, तो आगे की प्रॉब्लम नहीं बनेगा. सो आई वांट फ्रॉम ऑल ऑफ यू, इज द कंप्लीट स्टोरी इज क्लियर और नॉट? एनी स्टोरी विच यू हैव टू मग अप, कोई मग अप करने की जरूरत पड़ी क्या? नो, only the concept, that to pure concept. Is that clear or not? चलो, is that clear or not? आज मैंने बोला था बच्चा, आज की क्लास मजेदार होगी, और जो आज की क्लास मिस किया, those guys who have missed the today's class, they will be no problem. वो बाउंड्री लेयर समझते रह जाएंगे. आई नो कई लोग हैं बाउंड्री लेयर आज तक समझ ही नहीं आया है. वी स्टार क्या है? अमन पवार, you are asking V star क्या है? Have you completed your laminar flow? Have you completed laminar flow? There I have given you what is V star. I have explained you what is V star. Please watch the complete lecture. I have told you what is V star. Your friends will help you. V star is shear velocity, dear. Shear velocity. If exposed area is constant, you can't make it constant here. आप constant नहीं कर सकते, आप constant नहीं कर सकते. You can't make it constant. This boundary layer is formed not because of you. This boundary layer will form is not because of you. ये होता है, ये हमने देखा है और मैं आपको बता रहा हूं. This is something in all the things which I have told you, like laminar sublayer, more negative pressure gradient. These all things which we have observed, and that's something we are giving in a technical way to you. That's something we are giving in a technical way to you. Is that clear? Is that clear? Is that clear to all of you? Chalo. Now I'm going to something more. Now I'm going to something more. अब मैं थोड़ा सा आगे जा रहा हूं, ध्यान से समझना सब लोग. अब हमारे एक बाबा हुआ करते थे जिनका नाम था ब्लेसेस. हमारे दो बाबा होते थे जिनका नाम होता है ब्लेसेस. So what Baba has given? Baba has given laminar layer thickness for laminar. So laminar के लिए उन्होंने थिकनेस दिया, फॉर्मूला दिया, क्या दिया देखो, K into X upon root under RE. K into X upon root under RE. And for turbulent, he has given a formula K into X upon RE to the power 1 by 5. RE to the power 1 by 5. He has also mentioned when you have to tell it's laminar, when RE is less than or equal to 5 into 10 to power 5. And for turbulent, when RE is greater than 5 into 10 to power 5. Greater than 5 into 10 to power 5. With this, he has also mentioned you, K value for laminar, it is 4.6425. And for turbulent, K value is equal to 0.376. So where K is the Blase's constant, X is the distance from the leading edge. Always remember, distance we always measure from leading edge only. So delta laminar is the boundary layer thickness. Delta turbulent is the turbulent layer thickness. So Kx upon root under RE, RE to the power 1 by 4 for turbulent. What will be the RE range? That also I have given to you. What is the Blase's constant for laminar? That also I have given to you. Please make a note. Please make a note. Then I will ask you something. Here, RE will be equal to what? Formula क्या होता है RE का? Rho VD upon mu. Rho VD upon mu. That's something we can write as VD upon nu. VD upon nu. So what I'm writing in place of V, U. D is something we are not having, so that we are writing as X. So U infinity into X upon nu. So in a complete boundary layer theory, you have to use always Reynolds number is equal to U infinity into X upon nu. What is nu? Kinematic viscosity. Don't confuse between kinematic and dynamic. It is kinematic viscosity. So I have given you RE. X is the distance from the leading edge. Many question will be asked from this formula. Many question has been asked, and I'm also going to ask you so many questions. So distance from the leading edge. U infinity is the free stream velocity. And nu is kinematic viscosity. Kinematic viscosity. So all the details I have given to you. Now I can ask you something. That can be a 1 mark question. Important points. चलिए, first point. सब लोग मेरे साथ बताएंगे. You all guys have to give me the answer with me. सब लोग बताना कि what is the relation between the Reynolds number and the X value. Like if you are sorry, not Reynolds number, laminar, you can say the boundary layer thickness. So if you are increasing the x, your boundary layer thickness is increasing or decreasing. That means boundary layer thickness, that is the delta, and the x, is it directly proportional or inversely proportional? Is it directly proportional or inversely proportional? First statement from all of you. फर्स्ट स्टेटमेंट फॉर ऑल ऑफ यू. सब लोग जल्दी से बताइएगा. अरे भैया फॉर एग्जांपल देखो, मैं ऐसे जंप किया ना, मैं ऐसे जंप किया, सो दिस विल बी माय एक्सपोज्ड एरिया. आगे एरिया कम है, एट द फ्रंट एरिया इज लेस. एज आई एम गोइंग, देखो मैं बॉडी का एरिया ज्यादा है, तो एरिया आपका इंक्रीज हो रहा है. टेक एग्जांपल ऑफ एरोप्लेन. आगे का एरिया क्या होता है? इन फ्रंट एरिया इज लेस. As air is passing over the top, area is getting more na, more area is exposed na. So that is the reason I have given you two best example. One is human body itself, second thing is the aeroplane. Best example to understand. This is for who is asking about this? Aman, you are asking about Aman Singh. Yes, very good. That means delta is directly proportional. Is that clear or not? So I can write this statement. If the distance from the leading edge increases, boundary layer thickness also increases. Second point I'm asking to all of you. Now you guys will tell me, if the kinematic viscosity, if the fluid which is flowing, the kinematic viscosity of that fluid is increases. अगर आपने उस fluid की kinematic viscosity increase कर दिया, in that case boundary layer thickness will increase or decrease. सब लोग बताइएगा in a comment section. All guys have to reply me in a comment section. सब लोग बताइएगा in a comment section. If the boundary layer thickness will increase, or decrease, क्या होगा? Increase होगा, decrease होगा. If you are increasing the kinematic viscosity, look at the formula. जैसे आप kinematic viscosity increase करते हो, so in that case you know that delta laminar is inversely proportional to RE, and your RE is inversely proportional to what? Kinematic viscosity. In that case your delta will become directly proportional to kinematic viscosity. And a simple thing, see, जितना ज्यादा विस्कोसिटी होगी उतना ज्यादा क्यों हो रहा था? एरिया एक्सपोज्ड की वजह से आपका थिकनेस क्यों इंक्रीज हो रहा था? Why? Because if more area is exposed, more friction is there, more resistance is there. Similarly, if more viscosity is there, that means more fluid friction will be there. Again, more resistance will be there. Definitely the boundary layer thickness will increase. Even though if you are not knowing the formula, logically also you can give it. So what I am going to write down, मैं लिख रहा हूं boundary layer thickness with respect to the kinematic viscosity. मैं आपको लिख रहा हूं. Now you guys will tell me. अब मैं थर्ड स्टेटमेंट आपसे पूछ रहा हूं. मैं क्या पूछ रहा हूं आपसे? कि if I'm increasing the velocity of the fluid stream, in that case your boundary layer thickness will increase or decrease. मैं आपसे बहुत ही क्लियर पूछ रहा हूं, आराम से जवाब देना. तब तक मैं आपको सेकंड पॉइंट लिख देता हूं. आप सब लोग का कमेंट सेक्शन में रिप्लाई आ जाना चाहिए. So if the kinematic viscosity is increasing, or in a single line if I will write down, if that is increasing, that means delta is also increasing. Third point. Now my question is that if u infinity, that is a free stream velocity, if that is increasing, what will happen with the delta? Will it increase or decrease? It will decrease. Do you remember I have told you that negative pressure gradient wala part, because of the negative pressure gradient, the velocity is more. If velocity is more, in that case the boundary layer thickness is getting less. So this you got with the this formula also. इस formula से भी आप देख सकते हो कि your delta is inversely proportional to u infinity, is inversely proportional to u infinity. So if your u infinity is more, your delta will be less. Your delta will be less. I don't think so anybody will have any problem. I don't think so anybody will have any problem till now. किसी को भी यहां तक कोई भी प्रॉब्लम हो तो बताना. अभी तक किसी को कोई भी प्रॉब्लम हो तो बताना. अभी तक किसी को कोई भी प्रॉब्लम है तो बताना. यहां तक सबका क्लियर होगा. स्लोली आई एम गोइंग टू द न्यूमेरिकल पार्ट. स्लोली मैं न्यूमेरिकल पार्ट में जा रहा हूं, तो आप ध्यान रखना. फर्स्ट ऑफ ऑल, दिस ब्लेसेस फॉर्मूला यू गाइस हैव टू रिमेंबर इट, बिकॉज मेनी क्वेश्चन विल बी आस्क्ड फ्रॉम दिस फॉर्मूला स्पेसिफिकली. कुछ गेट के प्रॉब्लम भी मैं आपको करवाऊंगा जो इस फॉर्मूला से आए हैं, तो ध्यान रखिएगा. नेक्स्ट, velocity variation or in boundary layer. In a boundary layer. So I'm just showing you the diagram which I have shown you at that point. मैं थोड़ा अभी इसको और अच्छे से बता रहा हूं आपको, और कुछ भी नहीं है, थोड़ा बिगर पिक्चर बना के बता रहा हूं. Ultimately it's same only. Here we are having u infinity. Here we are having delta u. This one is delta. This distance is y. This distance is y. So if you assume linear variation, in that case you can write u infinity upon delta, similarity rule upon equal to u upon y. So u will be equal to y upon delta into u infinity into u. U is nothing but the general velocity. So u will be equal to y upon delta into u infinity. So this is the velocity variation, and if you are assuming linear variation, this will be the output. This will be the output. अब मेरे को कुछ चीजें बताना जो मेरे को बहुत ही ज्यादा इंपॉर्टेंट है. The next thing is very important for you your numerical. आराम से बताना. I hope you guys have noted down. आप सबने नोट कर लिया होगा this part. So can I go to the next part or not? क्या मैं next part में जा सकता हूं या नहीं जा सकता हूं? क्या आप लोगों ने नोट कर लिया यहां तक? Have you guys noted down? Have you guys noted down? Have you guys noted down? Yes or no dear? Yes or no dear? कमेंट करके बताइए जल्दी से. चलो, अब कुछ चीजें मेरे को बताना आप सब लोग. फर्स्ट थिंग सब लोग बताना. If I want to make a relation between delta and Reynolds number, especially for laminar. So you know that for laminar layer, the formula is what? Kx upon root under Re. So I can say that delta laminar is inversely proportional to root under Re. So क्या मैं इसको ऐसा लिख सकता हूं? Delta laminar for 1 upon delta laminar for 2 will be equal to root under Re2 upon root under Re1. Can I write like this or not? Can I write like this or not? क्या मैं ऐसा लिख सकता हूं या नहीं? क्या मैं ऐसा लिख सकता हूं या नहीं? आई एम आस्किंग टू ऑल ऑफ यू. एंड दिस रेशियो आई कैन यूज इट फॉर व्हाट? ये जो रेशियो मैंने अभी निकाला, दिस आई कैन यूज इट फॉर व्हाट? For same fluid also, and for same plate also. In a same plate and same fluid region, we can use this condition that delta laminar for 1 upon delta laminar for 2 will be equal to R root under RT2 upon RT1. Because in problem, they are going to ask you like this only. You have to make a relation between two quantity. You have to make a relation between two quantity. So I'm just teaching you how to get that relation, how to be confident that you will get a relation. So first thing I got. अब आप लोग second बताओगे. You guys will tell me second. So second I'm telling you delta laminar with u infinity. आप लोग बताओगे क्या होगा रिलेशन, whether it will be a inversely proportional or directly proportional. पहले तो ये क्लियर करो, whether it will be inversely proportional or directly proportional. सब लोग साथ में बताना, whether it will be a inversely proportional or directly proportional. So this formula is valid for entire boundary layer. Which formula you are talking about, dear? Which formula you are talking about, dear? Is it about this formula? This formula is valid. This formula is valid for entire boundary layer. क्योंकि ये तो एक जनरल है ना आपका, और ये जो आपका है ये आप बेसिकली कहाँ के लिए बना रहे हो? ये लेमिनार पार्ट के लिए आप बना रहे हो. टर्बुलेंट का हम कंडीशन बाउंड्री लेयर में कोई वेलोसिटी वेरिएशन की बहुत दिक्कत है. वहां इतनी ज्यादा वेरिएशन आपको दिखेगी कि आप उसको मेजर भी नहीं कर पाते ढंग से. जीकॉन ब्लॉग नवंबर 2 से प्लस पे क्रैश कोर्स होगा या कंप्लीट? इट इज नॉट अ क्रैश कोर्स डियर. That course is only for GATE. So definitely the time required for ESE will not be there. So it is not a crash course. It is a complete course, but that is strictly for GATE. So from 2nd November, the fluid mechanics which I am going to start on plus, in that case it is strictly for GATE. Because right now GATE 21 is there, so I am strictly focusing only for GATE. This is for you, Jicon blog. Chalo. So Aman is telling me inversely. So that means dear what? Delta laminar will be under root or not? Whether it will be under root or not? Yes, it will be under root. So I can write this as what? Delta laminar for 1 upon delta laminar for 2 will be equal to root under u infinity 2 upon u infinity 1. Chali. So again I got this part. This will be valid for two different fluid because speed is different now. To do two different fluid, same plate आप रख सकते हो, same plate. So this relation will be valid for two different fluid having same plate. Same plate आपने same रखा. चलिए, next I am telling to you. Next. Tell me a relation between delta and x. Now I want a relation between delta and x. Delta and x. देखते हैं इस बार कौन देता है. Yes, Jicon, if you are preparing only for GATE, you can join that course. If you are on plus, you can join that course. चलिए, सब लोग बताइएगा. Tell me a relation between delta and x. Tell me a relation between delta and x. Tell me a relation between delta and x. If those are different fluid, then kinetic viscosity is changing now. Then how can you take that? For different fluid, see, for a different fluid, why I have taken that different fluid? Because free stream velocity of different fluid I am taking. Free stream velocity of different fluid I am taking. Basically, that statement which I am giving for a particular condition. So don't go for that condition. Always remember the basic formula and then do it. Is that clear to you? Here I am telling that two different fluid I am taking. Or that means I am taking two different fluid. Like it can be of same material. So in that case, in the same material, the fluid viscosity will be same, but both the fluid are moving with a different velocity. That's something I'm trying to say. That's something I'm trying to say. Is that clear to you? Is that clear to you? Sure. So as you guys are telling me, sir, delta is proportional to root under x. So what is the formula for delta? We have kx root under RE. So that means delta will be equal to k into x upon RE is what? Root under u infinity into x upon nu. So I can write simply that delta is directly proportional to 1 upon, root under x. So delta is directly proportional to root under x. So you can write it like delta 1 for delta 2. This is both for laminar, na? Is equal to root under x1 upon root under x2. Root under x1 upon root under x2. So this you can write out, and this is for laminar condition. I am solving only for laminar because problem will be mostly asked from laminar only. You can do it for turbulent also, no problem. You know the formula of turbulent के लिए भी कर सकते हो. So you got a relation between delta laminar and delta laminar 2. That will be equal to root under x1 upon root under x2, root under x1 upon root under x2. Is that clear to all of you? क्या ये बातें सबको समझ में आ गई? अगर आपको ये तीनों relation, if you guys have got all the three relation correctly, can I ask you one question? Can I ask you one question? If you guys got completely about 1, 2 and 3, how I have done that 1, 2 and 3, can I ask you one question? And let's see how many of you guys are giving me correct result. How many of you guys are giving me correct result? देखते हैं कितने लोग सही जवाब देते हैं. So are you guys ready for that? Are you guys ready for that? क्या आप सब लोग ready हैं बच्चा? चलो. So I am going to give you the fourth one. The fourth one. Tell me a relation between tau and x. Tell me a relation between tau and x, where tau is the shear stress and x is the distance from the leading edge. Tell me a relation between that. देखते हैं कितने लोग दे पाते हैं. Let's see how many of you guys are able to form that relation. How many of you guys are able to form that relation? Let's see how many of you guys are able to form that relation. Sorry. Let's see how many of you guys are able to form that relation. सुरेश, नवंबर में आपको YouTube पे सिर्फ में इन्वायरमेंट का क्रैश कोर्स, नाउ यू नो दैट क्रैश कोर्स इज नाउ चेंज टू वीकेंड टू वीकडेज, ताकि आपके कोर्स गेट के पहले कंप्लीट हो. Because of that only we have taken a decision that now we will take crash course on weekdays also, so that your crash course will be completed for all the subject before gate exam. And in normal month in YouTube I will take only that crash course. My other classes are on plus. चलो 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 देखते हैं क्या क्या सवाल, क्या जवाब आ रहा है आप लोगों का. What is the answer? What is the answer, guys? What is the answer? चलिए 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 चलिए, सिर्फ 2-3 लोगों ने जवाब दिया है अभी तक. चलो. So you got that delta 1 upon delta 2 is something what you got? Something what you got? Root under x1 upon root under x2. If I'm not wrong, you got this. Now you know that tau formula. You all guys are knowing the tau formula. What is the tau formula? Mu into du upon dy. I hope you guys are knowing. So first part is something this. Now tau is equal to mu. We got a general relation for u in a boundary layer theory. We got a general relation, that is y upon delta u infinity, y upon delta u infinity. So differentiate that with respect to y. So what we got, y upon delta into u infinity. So if you differentiate with respect to y, delta and mu is nothing but the constant that will be come out, and y, differentiation of y with respect to y, it will be 1 only. So tau, what we are getting, mu into u infinity into delta. That means this tau is inversely proportional to delta. That means this tau is inversely proportional to delta. From this we can write that tau is inversely proportional to delta. So tau is inversely proportional to delta, and delta is directly proportional to x1, x2. So I can directly write it here. I can directly write it here. From this part, this will be the second, this will be the first. So you can directly write from combination of combining first and second, what you are getting, tau 1 upon tau 2, tau 1 upon tau 2 will be equal to root under x2 upon root under x1, root under x2 upon root under x1. That means your tau is inversely proportional to x. That is the reason I have also told you that. At less distance, shear stress will be more. ये बहुत ही प्यारा क्वेश्चन है कि in a laminar boundary layer the shear stress will be more. At the entrance you will feel the more stress. जब आप पानी में जंप करते हो तो स्टार्टिंग आपको ज्यादा झटका लगता है, स्टार्टिंग वाली पार्ट में आपको ज्यादा एक्सर्ट, ज्यादा स्ट्रेस फील होता है. So that is the reason, because here you can see that tau is inversely proportional to root under x. Tau is inversely proportional to root under x. That means when x is less, shear stress will be more. When x is less, shear stress will be more. One of the very important outcome, and this I will give you 5-star for this, because so many problems came from this point, so many questions, objective question came from this point, so many concept is there from this point, concept is related to this point. That is the reason for this I am giving you 5-star. For this I am giving you 5-star. Is that clear to all of you? Is it clear to all of you? Is it clear to all of you? Suresh, OCF wala part I think start hoga, I think. For crash course also the OCF will come. No problem. That will also come. Don't worry. That will also come. Don't worry. In crash course also that will also come. Is it clear to all? Is it clear to all? यहाँ तक सबको clear है? एक problem बनाए क्या? Can we solve a problem here? एक छोटा सा problem देखते हैं whether you guys are able to do it or not. Let's solve a problem, guys. Let's see whether you guys are able to do the gate problem or not. Are you guys confident? Chal. So in front of you, one question I am giving to you. This problem has been asked in GATE 2006 for 2 mark. This problem has been asked in GATE 2006 for 2 mark. And let's see how many of you guys will get the 2 mark. How many of you guys will get that 2 mark? कितने लोगों को वो 2 मार्क मिलते हैं? चलो. Let's see how many of you guys are getting that 2 mark. चलिए जल्दी बताइएगा सब लोग. द थिकनेस ऑफ द लैमिनार बाउंड्री लेयर on a flat plate at a point A is 2 centimeter and at a point B 1 meter downstream of A is 3 centimeter. What is the distance of A from the leading edge of the plate? Let's see how many of you guys are able to do it. Let's see how many of you guys are able to do it. चलिए सब लोग कीजिएगा, सब लोग कीजिएगा. आई वॉन्ट रिप्लाई फ्रॉम ऑल ऑफ यू. सारे लोगों से बनना चाहिए, एक दो लोगों से बनने से कुछ नहीं होगा. आई वॉन्ट ऑल ऑफ यू गाइज टू सॉल्व दिस प्रॉब्लम. If you are able to solve this problem, it will give you immense confidence that you can solve a gate problem. इसलिए मैं आपको हमेशा गेट और ईएससी प्रॉब्लम सॉल्व करवाता हूँ, क्योंकि वो सॉल्व करने के बाद ना आपके पास एक कॉन्फिडेंस आता है दैट समथिंग इज वेरी गुड, दैट समथिंग इज वेरी गुड. इसलिए मैं आपको हमेशा गेट और ईएससी प्रॉब्लम ही सॉल्व करवाता हूँ. चलो 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 चलो, सबका आंसर आना चाहिए. ओनली वासु हैज गिवन द आंसर टिल नाउ, और वो भी सही है गलत है, दैट समथिंग आई एम नॉट अवेयर. सो आई एम आस्किंग टू ऑल ऑफ यू डियर, जल्दी बताइएगा सब लोग. I'm asking to all of you dear, please reply with your correct answer. और you want me to explain this? आप explain कर सकते हो. अगर आप चाहते हो कि मैं explain करूं, you can tell me, sir. But I don't think so. This question need explanation. I don't think so. This question need explanation. I'm expecting you all guys will give me the right answer. आप सब लोग मेरे को सही आंसर दोगे. चलो Shashank is telling option A. Suresh also said. सृष्टि चंद्रा इज टेलिंग मी ऑप्शन बी. सृष्टि चंद्रा, आप इससे पहले एक्टिव नहीं थे. जस्ट नाउ यू बिकम एक्टिव, दैट मींस यू आर नॉट वाचिंग फ्रॉम स्टार्टिंग. चलो. So I don't think so this much time is required for this question. They are asking you thickness of boundary layer over flat plate, and they are going to relate. They are relating with the distance from that means they are relating with the x value. So you know that for laminar boundary layer, delta 1 upon delta 2 is equal to what? Root under x1 upon root under x2. I hope you guys are knowing this thing. So it will be 2 upon 3 will be equal to root under x upon root under x plus 1 meter. So what is the value you guys are getting if you calculate this? So 2 by 3 root under x upon x plus 1. If you solve this, So I am getting x equal to 0.8 meter. So option B is correct. So Vashu has given me correct answer. Srishti Chandra has given me correct answer. And Aman and Manish also have given me correct answer. सृष्टि आप स्टार्टिंग से देख रहे हो बट कमेंट में नहीं थे इसलिए मेरे को लगा आप नहीं हो. जितने लोग कमेंट में रहते हैं मैं तो समझता हूं उतने ही लोग हैं बस, क्योंकि वही इंटरेक्टिव है, मतलब वो समझ रहे हैं. चलो एक और क्वेश्चन करने का मन कर रहा है क्या? चलो एक और क्वेश्चन से पहले कुछ पढ़ते हैं. फर्स्ट अंडरस्टैंड समथिंग न्यू अगेन, देन विल गो विद द प्रॉब्लम. चलो एक नया टर्म आपको समझाता हूं. आई एम गोइंग टू टीच ए, आई थिंक सम ऑफ यू गाइज आर नोइंग दैट, सम ऑफ यू गाइज आर हर्ड अबाउट दैट. आई एम गोइंग टू टेल दैट इन अ कंप्लीट डिटेल. Have you guys heard about this boundary layer separation? Boundary layer separation. Have you guys heard about this? Have you guys heard about this? Yes or no? Have you guys heard about this? What is boundary layer separation? क्या आप लोगों ने इस चीजों के बारे में जाना है? और अगर if you guys have heard about this boundary layer separation, where you have heard? मेरे को ये भी इंपॉर्टेंट है, मेरे लिए ये भी इंपॉर्टेंट है जानना कि where you have heard this, where this term, where this concept you have heard, because I have told you this concept. और मैंने वहां ये भी बोला था, at that point I have told you this also, that this point I will discuss in detail when I will discuss the boundary layer theory. When I will discuss the boundary layer theory. तो मैंने बताया था, जिन लोगों ने स्टार्टिंग से मेरा लेक्चर फॉलो किया है, they can tell me. Yes, very good Aman, very good. In a venturimeter, I told you that in a venturimeter losses can occur because of the boundary layer separation also, and that time I have not explained you what is boundary layer separation, but now I am going to tell you. चलिए ध्यान से समझिएगा सब लोग. वाशु फॉर क्रिकेट बॉल, उसके बारे में हम बहुत डिस्कस करेंगे, तो अभी क्रिकेट बॉल को नहीं लाते, ठीक है, वरना डिस्कशन कहां से कहां चला जाएगा. चलिए तो बाउंड्री लेयर सेपरेशन को समझते हैं बहुत ही सिंपल लैंग्वेज में. एवरीवन जस्ट लुक एट हियर. Everyone just look at here. चलिए now tell me here, velocity and pressure. We are talking about velocity and pressure. So in the convergent part, if you look at the convergent part, here if you look at, the velocity is decreasing or increasing. You can say the area of cross section is decreasing. So as the area of cross section is decreasing, your velocity will what? It will increase. Your velocity will what? It will increase. What about pressure? If your velocity is increasing, your pressure will decrease. I don't think so anybody will have any problem based on the Bernoulli equation. As you know that the datum head is same only. So अगर velocity increase कर रही है, तो pressure head को आपको कम होना पड़ेगा. So if velocity is increasing, pressure will be go down. And as you can see, as the flow is going in the divergent section, what will happen? Velocity is decreasing, but at the same time pressure is increasing. Velocity is decreasing, pressure is increasing. Now look at here. What is actually happening? In a convergent section, it is not a problem. I told you in a venturimeter also, problem is not in a convergent section. Problem is when the flow is diverging. That means in a divergent section the problem will come. What problem will come? Look at here. From this point to this point, if you look at this point to this point, the pressure is increasing. That means what? Here it will be high pressure and here it will be low pressure. So at the outlet it will be high pressure, at the inlet is somewhere at the in between it is low pressure. So आपको मालूम है, you guys are well aware that the flow can occur from high to low pressure, from high to low. तो अगर वो high to low flow हो सकता है ना, there will be a chance, but it is not going through. Why? Because there is some velocity, and with that velocity there is some momentum. So even though it's adverse pressure gradient, even though it's adverse means because it's a positive pressure gradient, that something is adverse for you, and that is the reason we are calling as adverse pressure gradient. So that pressure gradient is something not good for us. That is the reason we also call this as adverse pressure gradient. So even though it's adverse pressure gradient, your flow is going from this point first to second जा रहा है. क्यों जा रहा है? Because in that flow there is some momentum, and that because of that momentum this adverse pressure gradient is getting overcome. वो क्या कर रहा है? उसको overcome करके निकल जा रहा है. But what happens sometime when the momentum because of the velocity is not enough to handle that adverse pressure gradient. What I'm telling you, when this velocity or momentum of that fluid particles are not enough to handle that adverse pressure gradient, तो आपका क्या होगा? फ्लो बैकवर्ड होने लगेगा. और yes or no, I'm asking to all of you, क्या फ्लो बैकवर्ड होने लगेगा या नहीं? I'm asking to all of you dear, क्या फ्लो बैकवर्ड होने लगेगा या नहीं? Yes or no? I'm asking yes or no. I'm asking to all of you dear whether the flow will go in a backward or not, because see, this velocity because of that momentum, it is not enough to handle this adverse pressure gradient. In that case, now it is a high pressure, it is low pressure, the flow will go backward. और ये जो backward flow होती है ना, जो आपकी back flow हो रही है, it is starting from boundary only. ये boundary से start होता है. ये boundary flow जो होती है, ये boundary से start होती है. That means the flow boundary layer separation is not something separation. It is what? Reverse movement, backward movement, and that start from boundary. That is the reason we call this name as boundary layer separation. Is that clear to all of you? अब वहां मैंने आपको boundary layer separation नहीं बताया था, because here this point you need to understand why this boundary layer separation comes. It is nothing but the reversal of flow. And if reversal of flow will be there, आपकी flow इधर जानी थी. For example, look at here. ये आपको दिख रहे हैं? तो ये चार जो आपके फिंगर हैं, ये चारों इस डायरेक्शन जा रहे हैं. All the finger are going in this direction. But what happens? The outer finger, this one and this one, it is not going. It is not contributing into the flow. It is not contributing in this flow. In that case, what will happen? There will be a loss. So if some part of the fluid particles are not going in the right direction, right direction, there will be a loss, and that is the reason in the venturimeter we are giving this divergence section in such a way that that velocity will be always maintained, so that even though it's an adverse pressure gradient, your boundary layer will not separate. The boundary layer separation will not occur. That means your flow will not get reversed. Is it clear to all of you? Is that funda is clear to all of you? Yes or no? Is that funda is clear to you? All of you. I'm asking to all of you dear. सबको ये फंडा समझ में आया? अरे yes or no बाबा? Yes or no? जल्दी बताओ रे बाबा. अरे हाँ या ना? Is that clear to all of you or not? Is that clear to all of you or not? Is that clear to all of you or not? फटाफट बताना बच्चा, फटाफट बताना, सब लोग बताना. क्लियर है? अब इसी पॉइंट को मैं थ्योरेटिकल वे में आपके लिए लिख देता हूं ताकि आपको याद रहेगा. फिर अगेन आई विल शो इन अ डायग्राम पार्ट आल्सो. ध्यान से लिखना, मैं आपको थ्योरेटिकल वे में लिख रहा हूं, आप सब लोग ध्यान से लिखिएगा. When fluid flows in a converging section, मैं ये आपको थ्योरी इसलिए लिखवा रहा हूं ना, why I'm giving this theory to you, because if you are watching this after 5 months also na, everything will be clear to you, or if you are simply reading the PDF of the class notes also, that also will be enough for you. So in that is the reason I am giving this theoretical part for you. When a fluid flows in a convergent section, velocity increases and pressure decreases. This flow we call as accelerated flow. This flow we call as accelerated flow. In case of divergent section, in case of divergent passage or section, velocity is decreasing and pressure is increasing. This flow we call as deaccelerated flow. Deaccelerated flow. This flow we call as deaccelerated flow. Now here, in the deaccelerated flow zone, in the deaccelerated flow, fluid is under positive pressure gradient. Fluid is under positive pressure gradient if velocity reduction is more, at some point of time, momentum may not be able to support the flow, and hence flow may reverse its direction. Flow may reverse its direction from the boundary. This is known as boundary layer separation. Boundary layer separation. This boundary layer separation occur at positive pressure gradient that is known as adverse pressure gradient. अब ये तो मैंने आपको theoretically बताया. Now I am going to show you in a diagram format also how this boundary layer is separated, how this boundary layer separation occur. That's something I am going to show you in a diagram part also, and there I am going to tell you about 1 mark question. एक mark का question मैं आपको explain करने वाला हूँ. So first thing you understood that in a boundary layer separation will exist only when there is a positive pressure gradient in the deaccelerated flow region, or in the deaccelerated part, or in the divergent part. So first is that adverse pressure gradient. That means positive pressure gradient is required. That means what? dp upon dx is required. dp upon dx should be greater than 0. ये चीजें होनी चाहिए. This thing is clear. इसके बाद भी not always, what I told you that not always in a positive pressure gradient, the boundary layer separation will exist. Why? मैंने बोला ना कि जब आपकी वेलोसिटी की जो मोमेंटम है वो ओवरकम कर रही है, जब तक वो इनफ है, in that case it will not be a problem. जब velocity will be reduced, the velocity reduction will be in such a way that it is not able to carry, it is not able to overcome the adverse pressure gradient, in that case your flow will be in a boundary layer separation part. तभी आपका boundary layer separation होगा. It is not always in a adverse pressure gradient boundary layer separation will occur. There is some specific condition. And that condition I am going to tell you. So everyone just look at the diagram. एक बार डायग्राम देखोगे ना बहुत ही मजा आएगा. एक बार डायग्राम देखो, सब लोग आराम से डायग्राम देखो. राइट नाउ आई एम नॉट लुकिंग इन द कमेंट सेक्शन. मैं कमेंट सेक्शन नहीं देख रहा हूं बिकॉज आई विल लुक द कमेंट सेक्शन ओनली एट द लास्ट. Once I will explain all the three, then I will see the comment section. So don't worry. अभी पहले कहानी सुन लो. First listen the story first. Now you know that all the three cases which I am going to show you, in all the three cases dP upon dx is greater than 0. dP upon dx is greater than, that means it's a positive pressure gradient. In that also I am showing you three sides. So one is du upon dy is greater than 0. One is du upon dy is greater than 0, that means it's a positive. Here du upon dy, or instead of that I will write it here, du upon dy is 0, and this last one is du upon dy is less than 0. That's something you can call as negative. अब ध्यान से देखिएगा यहाँ पे क्या हो रहा है. When it is greater than 0, simply flow is going on, simply जैसे जा रहा था. Normally the flow is going on because velocity is enough to handle the adverse pressure gradient. But when you du upon dy, when the du upon dy is equal to 0, that means देखो क्या हो रहा है यहाँ पे. If you guys have noticed the diagram, you will find that there is something changes from the boundary. Boundary से आपको दिख रहा होगा कुछ changes दिख रही है. There will be something contraction. When this du upon dy, that means it's negative. What is the meaning of that du upon dy is negative? That means that the velocity changing from the first point to the second point, this first point to the second point is not that much to handle the adverse pressure gradient. अगर मैं बोल रहा हूं 1 to 2 में अगर आपका dv upon dy आपका negative बोल रहा हूं, that means क्या है आपका, there will be V2 value less than the V1. In that case आप देखना कैसे फ्लो हो रही है. टिकड़ी आपको फ्लो में कुछ समझ में आया? Just by looking diagram, have you understood this? In the bottom, in something in the, you can say near to the boundary layer, you will find that flow is reversed. Flow की डायरेक्शन क्या हो गई है? रिवर्स हो गई है. Actual flow इस डायरेक्शन में जा रहा था, now some part of flow is going in a reverse direction, and that's something we call as boundary layer separation. So this part we call as attached flow. This part we call as separation point, जहां पे about to separate है, या separation point बोल दीजिए इसको आप. And this is separated flow. So have you guys understood the diagram? अब मैं comment section देख रहा हूं, तो you can ask your question. Have you guys understood the diagram? कौन सा point repeat करना चाहते हो? कौन सा point? I can show you each and every slide once again. So this is the boundary layer separation. For every slide I am waiting for you. जो भी slide आपको repeat करना है, you can tell me. Have you guys understood this boundary layer separation or not? क्या आप लोगों को boundary layer separation समझ में आया या नहीं आया? Have you guys understood this boundary layer separation or not? कौन सा पॉइंट, कौन सा पॉइंट? कौन सा सेम पॉइंट है भैया? At some point of time, momentum may not be, at some point of time, momentum may not be able to support, may not be able to support, यहाँ पे देखना, able to support the flow, and hence flow may reverse its direction, and hence flow may reverse its direction. चलिए, is that clear? Boundary layer separation समझ में आया या नहीं आया? Whether you guys have understood with this diagram or not, whether you guys have understood this with the diagram or not. So it means in a Venturi meter, the vena contracta is the separation point. No, 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 dear. Don't take that. Don't relate that. Is that clear now? Chaliye. So we are writing something more in this. We are writing something more in this. So at the separation point, people will ask you the condition. In exam, they will ask you the condition. So at the separation point, what is the condition what we are having? First condition is at the separation point, dP upon dx will be greater than 0. That means positive pressure gradient. That is something which is very much required. And second thing is that your du upon dy or dv upon dy should be equal to 0. So at the separation point, you will find these two conditions. At the separation point, you will find these two conditions. तो ये बात हमारे में बिल्कुल क्लियर हो गया. अब बोलोगे सर जब आप डिस्कस कर रहे हो, when you are discussing about boundary layer separation, you are telling me sir how this boundary layer separation is occurring. आपको ये भी बताना होगा सर how we can prevent this, how we can reduce this, वो भी आप बता सकते हो, ये भी आप बता सकते हो. देखियो, so in order to prevent the separation of boundary layer, and this can be asked in 1 mark problem. कई बार मैंने देखा है मैच द फॉलोइंग क्वेश्चन में ये चीजें पूछ देता है. So in order to prevent the separation of boundary layer separation, फर्स्ट थिंग क्या करते हैं हम लोग देखो, कर्वेचर ऑफ object is minimized. Curvature of the object is minimized. Second thing is the divergence angle. So remember in a Venturi meter I told you that in a divergent section the angle will be in a such a way that complete flow will go with attached flow. Complete flow will go with as attached flow. So divergence angle should be within the limit. Should be within limit. Third, surface roughness of the object. Surface roughness of the object shall be improved. Shall be improved. So these are the things which you can do. Generally we are doing in our Venturi meter also. Curvature object हम का सही रखते हैं या फिर डाइवर्जेंस एंगल मेंटेन करते हैं या इंटरनल जो सरफेस की रफनेस है वो भी हम इंप्रूव करते हैं. So these are the things which we can do to prevent it from boundary layer separation. So these all three things they can ask you in a 1 mark question. So remember this thing. They can ask you what is the statement for at the separation point. They can ask you this diagram also and they can tell you in which case boundary layer separation is occurring. ये भी चीज आपसे पूछ सकते हैं. They can ask you in which pressure gradient the boundary layer separation will occur. It will the adverse pressure gradient and that too positive pressure gradient. तो इस बात को ध्यान में रखना. Question can be asked, especially the objective question can be asked from this boundary layer separation point. So I don't think so anybody will have any problem. Up to this किसी को कोई भी problem है तो बताओ. Up to this anybody having any problem they can tell me. अभी तक किसी को कोई भी प्रॉब्लम है तो बताओ. अभी तक किसी को कोई भी प्रॉब्लम है तो बताओ. सरफेस रफनेस शुड बी मोर और लेस. मोर रखोगे तो आपको लगता है कि बाउंड्री लेयर आपको कैश फ्लो होने देगा. अमन लॉजिकली सोचो, अगर बाउंड्री सरफेस अपने ज्यादा रख दी रफनेस तो आपको लगता है इट इज गुड फॉर अस. क्लियर है? चलिए, सो आई होप आई हैव गिवन ऑल थिंग्स रिगार्डिंग बाउंड्री लेयर सेपरेशन टू यू. ठीक है, चलिए, तो आप लोग में थोड़ी जान बची है. थोड़ी जान बची है. 1 घंटे और वाला जान बचा है कि नहीं? आर यू गाइस एक्साइटेड फॉर द नेक्स्ट लास्ट 1 आवर और नॉट? क्योंकि बाउंड्री लेयर सेपरेशन में ना हर चीजें समझना है. यू नीड टू अंडरस्टैंड, यू नीड टू यूज योर ब्रेन. So that is the reason I'm asking to you. So are you guys ready for the next 1 hour? Yes or no? I want in the comment section. Is it clear? Is it clear to all of you? चलिए, तो अगर आप सब लोग रेडी हो तो हम लोग चलते हैं नेक्स्ट पॉइंट की तरफ. और नेक्स्ट आई एम गोइंग टू डिस्कस इज नथिंग बट द डिस्प्लेसमेंट थिकनेस, मोमेंटम थिकनेस एंड एनर्जी थिकनेस. बहुत ही प्यारा पॉइंट है. दैट इज डिस्प्लेसमेंट थिकनेस First, I will give you the definition and then I will give you the complete detail about how this formula key. तो मैं आपको पहले डिस्प्लेसमेंट थिकनेस का डेफिनेशन देता हूं. राइट डाउन. It is distance by which, I will tell you in detail. First, write down the definition by which boundary should be displaced. Boundary should be displaced. Should be displaced in order to compensate the losses, or in order to compensate the reduction in mass flow rate. Right now you will not get this definition. क्या लिखा सर आपने? लेकिन मैं एक एक लाइन आपको एक्सप्लेन करूंगा. So it is the distance by which boundary should be displaced in order to compensate the reduction in mass flow rate. अब इस बात को समझते हैं कि सर ये हो क्या रहा है, क्या लिखा सर आपने, मेरे को कुछ समझ नहीं आया. लेट्स ओके, नो प्रॉब्लम. समझिएगा ध्यान से, सब लोग समझिएगा ध्यान से. फॉर एग्जाम्पल, दिस इज योर प्लेट and you have made a boundary layer theory. So this part, okay, this is the velocity. Okay, if that boundary layer will not be there, that means if that plate is not there, अगर वो प्लेट नहीं होता, if that plate will not be there, in that case क्या होता? ये कैसा होता बच्चों आपके पास? ये कंप्लीटली कैसा होता आपके पास, कुछ ऐसा होता क्या? It will be completely, it will be like this, it will be like this. Yes or no? कुछ ऐसा होता क्या? So because of the boundary layer formation, आपको देख रहे हो कितने लॉसेस हो रहे हैं, कहां लॉस हो रहा है आपको? This part is going as a waste, this part is going as a waste. So in this much part, whatever the mass rate can flow, which can flow, but because of this boundary layer, that part is not able to flow, that part is not able to flow. Yes or no? It is clear to all of you or not? ये बातें समझ में आई या नहीं कि वो जो आपका एक्स्ट्रा पार्ट लॉस हो गया उसके बारे में बात कर रहे हैं हम लोग, how to compensate that, that's something people are focusing about. तो सबसे पहले तो आपका क्वेश्चन होगा, फर्स्ट ऑफ ऑल यू गाइस विल आस्क मी हाउ मच रिडक्शन इज अकरिंग, द फर्स्ट थिंग यू गाइस आर आस्किंग मी, सर हाउ मच रिडक्शन इज अकरिंग, इस बात का देखिएगा सब लोग। तो पहले हम क्या करते हैं, एट व्हेन नो बाउंड्री लेयर इज देयर, when no boundary layer is there, when no boundary layer is there, in that case if I am writing mass flow rate क्या होता है फॉर्मूला, रो ए बी, क्या होगा, रो दिस प्लेट इज गोइंग विद द डेप्थ, आप इसका डेप्थ बोल सकते हो कितना, v बोल सकते हो, b, and what I'm taking, I'm taking a small cross section, for the small cross section what will be the value, b into dy into velocity will be what, velocity क्या होगा, जब बाउंड्री लेयर नहीं रहेगा तो स्पीड क्या होगी, u इंफिनिटी होगी, so it will be u infinity. Next, when boundary layer is there, is present, अब क्या होगा, m dot will be equal to रो, अभी भी छोटा एलिमेंट है तो उसका dy थिकनेस है, so b into dy, that is the area, into this time the speed will be what, u only, because this time boundary layer is there, so u infinity cannot flow, so it will be only u only. I don't think so anybody will have any problem. किसी को इस बात से कोई प्रॉब्लम है तो बताओ. So how much reduction happened, आपको फॉर्मूला से भी दिख रहा होगा कि when boundary layer is not there, in that case the mass flow rate will be more. This you can see in the diagram also. When boundary layer is there, in that case the mass flow rate is less. So definitely if I will find out reduction, if I will write down reduction in mass flow rate, it will be what, rho b into dy, that means this much minus this much, so it will be u infinity minus u. I don't think so anybody will have any problem. Rho into b into dy into u infinity minus u. I don't think so anybody will have any problem. So now what we are doing, theoretically what we are doing, we know that कि ये losses को हम compensate तो कर नहीं सकते. So what we are telling that if you will increase this, देखना क्या कर रहा हूं, हम अगर थोड़ा सा पार्ट को डिस्प्लेस कर देते हैं, take about this part, समझ लो, that means some part we are displacing, this thickness is already delta, so now we are displacing this boundary layer with some distance delta star, that's something we call as displacement thickness. So we are displacing this, can in real life we can displace, no, these all things we are doing in a theoretical way, सिर्फ theoretical way में हम कर रहे हैं कि अगर उसको displace किए, कितने थिकनेस डिस्प्लेस किया हमने, डेल्टा स्टार, जो आपका डिस्प्लेसमेंट है थिकनेस वो कितनी है, डेल्टा स्टार, एंड that can compensate this loss, this part, this mass rate of flow can be compensated, or this reduction in mass flow rate can be compensated with this reduction in mass flow rate can be compensated with this. ये बात समझ में आ रही है? Have you guys got this? प्रैक्टिकली नहीं कर पा रहे हैं, प्रैक्टिकली वी आर नॉट, वी आर डूइंग ओनली इन अ थ्योरेटिकल वे कि वी आर डिस्प्लेसिंग, वी आर टेलिंग दैट इफ वी डिस्प्लेस दिस by what thickness, delta star, then that part can compensate with the all the losses which occurred because of the boundary layer. So this is the reduction in the boundary layer in the mass flow rate which occurred because of the formation of boundary layer. So that we are compensating by displacing this with a delta star. So whatever the reduction we got, that will be equal to the mass flow rate which is present in that displaced part. So that means rho b into dy into u infinity delta will be equal to mass rate in that displaced part. It will be again rho b into dy, and their speed will be what? U infinity only. Their speed will be what? Sorry, here it will be not dy, it will be delta star. It will be delta star. So now you can see that rho b can cancel out. Now this part is for a small section. So you have to write integration. You have to do that integration, and that to integration from 0 to delta, because this mass rate of flow which you have determined, this is for only for a small strip. आप सिर्फ इस strip के लिए find out किए थे. That's something dy. But you have to find out for whole na. So in that case, integration of this will be equal to rho into, so rho b is the constant. That's something we can cancel it out. Ultimately what you are getting, this delta star is equal to integration of 0 to delta u infinity upon u infinity will be 1 minus u upon u infinity bracket into dy. So this becomes formula for displacement thickness. I don't think so anybody will have any problem how I got this formula. किसी को भी किसी चीज पे डाउट है पूछ लो. Anybody having any doubt they can ask me. चलिए, everyone just comment up to this it is clear or not. 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 चलिए, नोट कर लिया सबने? Have you all guys noted down? Have you all guys have noted down? Yes or no? Have you all guys have noted down? So this is something which we got for displacement thickness. This is something which we got for displacement thickness. Similarly, you can do it for momentum thickness also. So next one is for momentum thickness. Again, look at here. First, I will write down the definition. The momentum thickness is defined as or you can also define as the distance by which boundary should be displaced in order to compensate the reduction in momentum of the fluid particles. Is that clear? Ab dekna, I don't need to derive this again. What you have to do in place, right now we have written for m dot. Now this time will be T. So here mass rate into velocity. Rate of change of momentum, so mass rate into velocity. Only thing we have to add this. So m dot will be rho a v into v square. So एक v आपका extra आ जाएगा और कुछ भी नहीं है. बाकी other things are totally same. You can derive this. So theta will be equal to 0 to delta u upon u infinity 1 minus u upon u infinity into dy. This is the value for theta. This is the value of theta which you got. So we are representing momentum thickness with theta, and this is equal to this one. Is it clear to all of you? Simply derivation part is totally same. You can do it, and if you are not able to do it, you can tell me. In the next class आप बता सकते हो. मैं जानबूझ के आपको दिया हूं because I want you to do it. Only thing you have to change is this part. Instead of this mass rate of flow, now we have P dot, that is mass rate into V. Only thing is that. So it will become rho a V into V. Other steps are totally same. No change at all. Sure. So this is something which we got, momentum thickness, and that we are representing with what? Theta. Next one. Energy thickness. Definition wise it's still the same. आप definition लिख सकते हो. It is the distance by which boundary layer is displaced so as to compensate the loss due to loss in energy. So I'm directly writing the formula. So we are representing this with delta double star, or sometimes we also call as delta E. It is 0 to infinity u upon u infinity 1 minus u upon u infinity whole square into dy. So this something we call as energy thickness. I'm not writing the definition for you. I'm expecting that you will write same definition है बस. First में क्या था? In a displacement thickness, it is a mass rate of flow. In momentum thickness, momentum rate of flow. In energy thickness, it is the energy part, energy loss. So to compensate energy losses, we are displacing our boundary layer, and that displacement distance we call as, or the distance by which the boundary layer is displaced, that's something we call as energy thickness. I have given you the formula. Now two things are important. One is the safe factor. People will ask you. Safe factor बहुत लोग पूछते हैं. So that is delta star upon theta. That is displacement thickness upon momentum thickness we call as shape factor. First point they will ask you this, and second point they will ask you कि कौन सा बड़ा कौन सा ज्यादा. ये बहुत पूछा जाता है. So for linear velocity profile, डेल्टा सबसे बड़ा, दैट इज द बाउंड्री लेयर थिकनेस. उसके बाद डेल्टा स्टार, उसके बाद डेल्टा ई, और उसके बाद थीटा. इट्स अ जनरल ऑब्जर्वेशन विच वी हैव सीन. डेल्टा सबसे बड़ा, डेल्टा स्टार उससे बड़ा, डेल्टा ई उससे बड़ा, और थीटा सबसे छोटा. इज दैट क्लियर टू ऑल ऑफ यू? सो फॉर अ लीनियर वेलोसिटी प्रोफाइल, you got the part, you understood what is displacement thickness, you understood what is momentum thickness, you understood what is energy thickness. Shape factor is very much required. Why? For what purpose? Because it explain you the shape of the body, and accordingly you can find out. So shape factor एक छोटा सा term है, कभी कभी आपसे पूछता है. It is nothing but ratio of displacement thickness upon the momentum thickness. So note it down. and sometimes they will also ask you in a linear velocity profile what is the relation. So delta सबसे बड़ा, उसके बाद डेल्टा स्टार, उसके बाद डेल्टा ई, उसके बाद थीटा. Remember this point. Remember this point. पीयूष बंसल हाइड्रोलिक पंप आप करवाओगे क्या? हाइड्रोलिक पंप वाला पार्ट मैं आफ्टर गेट एग्जाम करवाऊंगा. Why? Because in gate exam it is not there. So those who are preparing for gate exam, in hydraulic machine is not there for you. I will give you the complete lecture for hydraulic machine, including pump, turbine, everything. Pelton, Francis, Kaplan, all turbine I will discuss with you. Okay. So till now it is clear. Are you guys ready for the numerical? Are you guys ready for the numerical? क्या आप सब लोग numerical के लिए ready हैं? If you want me, I can show it to you all the part. So are you guys ready for the numerical? चलो एक न्यूमेरिकल करते हैं बच्चा. First tell me this. First tell me the right answer for this. This is the question and this is the options. You have these options. First look at the question and give me your answer. First look at the question and give me your answer. First look at the question and give me your answer. In front of you there is a question. I want all of you guys to attempt this. I want all of you guys to attempt this. चलिए बताइए आंसर बताइए सब लोग. Boundary layer thickness, decrease in the flow direction, increase in the flow direction. Shear stress at the plate, decrease in the flow direction, increase in the flow direction, remain unchanged. Pressure gradient along the plate, remain unchanged. क्या होगा? What will be the answer? What will be the answer? So Vasu is telling A ka 2, B ka 1 and C ka 3. Perfectly correct. Boundary layer thickness is increasing in the flow direction, so A ka 2. Shear stress at the plate is more at the leading edge. As you are going, as your X value is increasing, your shear stress will decrease. So it is decreasing the flow direction. So B ka 1. Pressure gradient along the plate, it is remain unchanged. So that's something we are writing. C ka 3. So A ka 2, B ka 1, C ka 3. So Vasu and Shubham also, I think he has given the correct answer. Sure. So 213. 213 is the correct answer. We are going to the next question. Chalo. Next question. Within a boundary layer for a steady incompressible flow, the Bernoulli equation. Within the boundary layer for a steady incompressible flow, the Bernoulli equation. Within a boundary layer for a steady incompressible flow, the Bernoulli equation. Within a boundary layer for a steady incompressible flow, the Bernoulli equation. Aman is telling me option D. Correct option will be option D, because does not hold because the flow is frictional. Frictional hoga, Bernoulli equation will not be valid. Bernoulli equation will not be valid. Is that clear? So in a boundary layer theory for studying compressible flow, the Bernoulli equation does not hold because the flow is frictional. Here in a boundary layer theory, viscous force is dominating. So if viscous force is dominating boundary layer, Bernoulli equation will not be valid. Why? Because Bernoulli equation is derived from, or it is derived for inviscid flow. Inviscid flow. We have taken only two forces in consideration for Euler formula. That is the pressure force as well as the gravity force. Viscous force we have not taken, we have neglected that part, and Bernoulli equation is just a, you can say, just a modified part of your Euler equation, just a modification in Euler equation. In that case, Bernoulli equation will not be valid when the flow is viscous or frictional. So if this point is clear, we are going to the next question. Try this one. Try this one. Can't be applied even with the head losses? No. Shashank will not apply even with the head losses also. Boundary layer theory will not use Bernoulli equation. Chaliye. Velocity profile inside the boundary layer for a flow over a flat plate is given as u upon v infinity is equal to sine pi by 2 y upon delta, where v infinity is the free stream velocity. Chaliye, try this question. You need to find out ratio between delta star upon delta. Delta star upon delta. That means displacement thickness upon boundary layer thickness. They are asking you ratio of that. चलिए जल्दी बताइएगा सब लोग. चलिए बताइएगा, आंसर बताइए सब लोग. I want reply from all of you, dear. चलिए रिप्लाई बताइए जल्दी से जल्दी से. Shubham, another is telling me 1 by 2. What about other guys? What about other guys? What about other guys? सिंपल कैलकुलेशन इज देयर. इतना टाइम कैसे लग सकता है? You know that delta equal to what? Delta star equal to what? 0 to infinity 1 minus u upon u infinity into dy. So delta star 0 to delta 1 minus u upon u infinity is given to you, that is sine pi by 2, sine pi by 2 into y upon delta. I think this only given to you. Chaliye, bracket closed. So delta star will be equal to integration of y minus sine integration, it will be plus minus cos. So cos pi by 2 y upon delta into 1 by a. So 1 by pi upon 2 delta, and the limit is 0 to delta. Limit is 0 to delta. So delta star will be equal to y plus 2 delta by pi, 2 delta by pi into cos pi y into cos pi by 2 into y by delta, and limit is 0 to delta. So delta star will be equal to what? Delta plus 2 delta by pi. If here I will put delta here, क्या होगा यहाँ delta? अगर मैं वहां delta डाल रहा हूं तो क्या होगा? So delta delta will be cancelled. 1 cos pi by 2, cos 90 will be equal to what? 0. So it will be 0 minus 0 plus minus 2 delta by pi cos 0. Cos 0 equal to क्या होता है? 1. So delta star will be equal to delta, this part will be cancelled, this part will be cancelled, minus delta minus 2 delta upon pi. So I will take delta as common, it will become 1 minus 2 by pi. So that becomes equal to delta star. So they are asking you, I think, delta star upon delta, it will be equal to 1 minus 2 by pi. 1 minus 2 by pi. Is it the option? No, I think it's a fill in the blank part. So it will be 1 minus 2 by pi. 1 minus 2 by pi. So शुभम आपने गलत आंसर दिया था. Anybody got this part? किसी को ये part आया था? Anybody got this part? Delta star upon delta. किसी का भी आंसर सही आया था? They can reply me. Anybody got the right answer? They can tell me. Delta star upon delta is equal to 1 minus 2 by pi. Anybody got this answer correctly? They can tell me. किसी ने भी इसका सही आंसर निकाला है तो बता दो. Anybody got the right result for that? They can tell me. Anybody got the right result for that? They can tell me. Chali. So this is the answer for the last question. We are going to the next question part. So this is the question. I'm expecting all of you guys will give me the right answer for this question. At least for this question, you guys will give me the right answer, and you all will give me the right answer. एक दो नहीं, सब लोग right answer दोगे. चलिए चलिए चलिए, सब लोग बताइएगा, सब लोग बताइएगा. You got 1 for this question, Vashu. For this question you are talking about or the previous question? आप इस क्वेश्चन के बारे में पूछ रहे हो या प्रीवियस क्वेश्चन के बारे में पूछ रहे हो? No, previous question you will get 1 minus 2 by pi. That means you have done somewhere, you have done the calculation mistake. Vashu, please do it. Generally calculation mistake होती है ये limit डालने में. Most of the guys are doing mistake here only. How to put this limit? वो जीरो वाला पार्ट को भूल जाते हैं. अमूल्य, you are having doubt in integration part? Yes, tell me dear, क्या doubt है यहाँ पे? I know ना, especially in limit, you all guys will do the mistake. While putting zero value, you will forget to take this part. You will forget to take this part. आप ये वैल्यू देख लेना भूल जाते हो. अगर आप cos 0 रखोगे तो इसकी वैल्यू 1 आती है ना. So it will be 2 delta by pi. This value will be there. You always forget this part. You always forget this part. I know. Is it clear now, Amulya? Chalo. Try this one. Try this question. Try this question. The displacement thickness at a section for the air stream that is rho equal to 1.2 kg per meter cube moving with a velocity 10 meter per second over the flat plate is 0.5 mm. What is the loss mass rate of flow of air due to boundary layer formation in kg per meter width of the plate per second? So that they are asking you m dot per unit width, m dot per unit. That is the reason kg per second per meter width. So B value they have given you. It's a very simple question. They are asking you what? Loss in reduction. So loss in mass flow rate will be equal to what? Loss in mass flow rate will be equal to what? Loss in mass flow rate. Just now I given you mass flow rate equal to what? Rho into B into delta star into U infinity. So rho they have given you 1.2 if I'm not wrong, into B they have given you 1 unit width. Delta star they have given you what? 0.5 mm. So 0.5 into 10 to power minus 3 into U infinity. How much they have given you? 10. कितनी आ रही है वैल्यू? What is the value you guys are getting? Whatever value you will get, that will be in a kg per second. That will be in a kg per second. बताइएगा जल्दी से. 1.2 into 1 into 0.5 into 10 to power minus 3 into 10. What is the value you guys are getting? क्या आ रही है आप लोगों की वैल्यू? What is the value you guys are getting? So Manish is telling me option A. Manish is telling me option A. आप कैलकुलेट कर सकते हो. This will be 10. So 10 cancel. 1.5 into 0.5. 1.2 into 5, it will be 6. 6 into 10 to power minus 3. So option is what? A. Correct option is option A. So I don't think so anybody will have any problem in this question. किसी को भी इस पार्ट में कोई प्रॉब्लम है तो बताओ. किसी को भी इस पार्ट में आज हमने क्या क्या डिस्कस किया? आई एम जस्ट गिविंग ए शॉर्ट डिस्कशन फॉर ऑल ऑफ यू. We have started with the boundary layer introduction. We have discussed the Blaze's formula. We have discussed. Introduction part we have discussed. Boundary layer thickness we have discussed. Boundary layer separation also we have discussed. And delta star, theta and delta E. That means displacement thickness, momentum thickness and energy thickness. All these things we have discussed. So today we have discussed all the basics for your boundary layer. हम लोग बाउंड्री लेयर का जो बेसिक्स है वो क्लियर हो गया है. अब एक और टॉपिक आपका बाउंड्री लेयर से रिलेटेड ही है, वो बोलूंगा मैं. दैट समथिंग इज drag or lift force that I need to discuss that part. Drag and lift force that I will discuss in the next class. So after this only the 2-hour class will be there for the fluid mechanics. Remaining topic like hydraulic machine or turbulent flow, that I will discuss. Turbulent flow I'm not going to discuss now because in GATE it is not important for you. And hydraulic machine, these two topics are remaining. Turbulent flow maybe on as a special class I will discuss that part maybe, or hydraulic machine will come as a separate unit. Hydraulic machine will come as a separate and that will come after GATE exam. वो मैं GATE exam के बाद लूंगा. Is that clear to all of you? ताकि उस टाइम आप लोग ESE के लिए इंटरेस्टेड रहो, तभी लेने का मजा है. अदरवाइज GATE पीपल आप लोग के लिए वो हाइड्रोलिक मशीन की कोई जरूरत है नहीं. So other than that so today अगर आप देखो तो आपका एक क्लास बस और आपका बचा है फ्लूइड मैकेनिक्स का. दैट आई विल टेक ऑन टुडे इज 30 ना, 31st and 1 Saturday Sunday. Monday we will take that class. So coming Monday we will take the last class of the fluid mechanics for this series. You can say for this series it is the last class of fluid mechanics and I hope you guys are enjoying. आप लोग ने FM enjoy किया या नहीं किया ये बताओ. From first lecture to total 37, one more lecture, total 38 lecture will come for fluid mechanics. Whether you guys have enjoyed this or not, मजा आया कि नहीं आया? I know fluid mechanics में आपको environment वाली crowd नहीं मिलती मेरे को. I know because fluid mechanics में दिमाग लगाना पड़ता है. जो बच्चे यहाँ हैं, they are using their brain, they are imagining that part. अगर imagination नहीं होगी तो फिर आप fluid mechanics नहीं समझ पाओगे. So imagination is very much required. So till now, if you have any doubt regarding these things, you can ask me. And today 1 p.m. to 1 p.m. or you can say from 1 p.m. time to kitna bhi ja sakta hai. From 1 p.m. we are having workout session on FM. And this workout session, I am asking question from OCF also. I am asking question from all the topic which I have covered till now. So I am very excited to give you that question and I hope you also guys are excited to solve that problem. So we will solve that. We will discuss something also. और देखते हैं मजा आता है कि नहीं. Is that clear to all of you? Is that clear to all of you, dear? Is that clear to all of you, dear? So we'll meet again at 1 p.m. आपको ये जो सेशन होती है, जो वर्कआउट सेशन होती है, आपको कहाँ पे होती है? एज ए फ्री स्पेशल क्लास ऑन Unacademy plus platform, Unacademy not plus platform, Unacademy platform. So those guys who are not able to see, कहाँ पे देखते हैं? कुछ भी नहीं करना है. इस वीडियो के डिस्क्रिप्शन सेक्शन में जाइए. आपको Unacademy का प्रोफाइल लिंक मिलेगा. You will get a profile link of mine. And you have to click on that, go to the free special class section. You will find the today's free special class, and today I am going to take free special class on this topic only. Complete around I have selected 29 to 30 question, and you guys are going to love it. So with that guys, no problem Purnima, you can watch the recorded one. If you are getting any doubt, you can always ask. Okay. With that guys, bye bye, take care. We'll meet again at 1 p.m. sharp and don't be late. अगर late हो, thank you guys.